All right, let's take a look at example here. So this one wants us to find the arc length of the semi-cubical parabola given by this function between the points 1, 1 and 4, 8. And then there's a picture over here given. So if we are going to find this arc length, we want to set up an integral from the start to the finish. Well, our a on this one would be 1, our b would be 4 here. So from 1 to 4, because those are our x values, of the square root of 1 plus our derivative here. So we're going to need to know what our dy dx or f prime is here squared dx. So what is this derivative going to be of this function? Two ways we could find that. We could use implicit, or we could solve for that y and do that. I think we could solve for the y by square rooting both sides here. Now, if you do that, it really is going to end up being here plus or minus the square root of x cubed. We can see from our graph here, though, that we are in the positive region. So I don't think we are going to have to worry about that negative, so we'll just use this function as y equals the positive value of that. And another way of writing the square root of x cubed would be x to the 3/2. So our derivative here, either y prime, or we could write that as dy dx is going to be 3/2 x to the 1/2. So that's our derivative. So let's put that in. So we get 3/2 x to the 1/2 squared dx. All right, so now to integrate that, let's square that first and simplify it. So it's going to be 1 plus 3 squared would be 9, 2 squared would be 4. X to the 1/2 squared, that's like square root of x squared, that's just going to be x. Okay, now at this point, a lot of these arc length ones are going to not be easy to integrate. So a lot of times, once you get to this step, you could, they're going to be on the calculator portion where you'd be able to use your calculator to do it. So let's do that. If we'd use our calculator and input that function, and I've kind of done that at this point right here already. From 1 to 4, you could hit it, and this would give you the approximate length of that line. So it looks like the arc length comes out to be about 7.634 here, rounded to 3 decimal points. So sometimes that's going to be all you have to do. If you would want to get the exact answer on this one, how would we integrate that? Looks like probably a substitution one. We could substitute in here for u the stuff under that square root and find it that way. So then our derivative here would be 9/4 dx. So if we make our substitution here, let's multiply by reciprocal, it'd be 4/9 du. So I'm going to change our integral. I'm going to put that 4/9 out in front because that's a constant. This is going to become then just square root of u du. And then either you have to leave those limits alone or substitute back in later. Or change them now. I'm going to change them now. So what would those limits be if we were to put in 1 and 4? Well, u at 1 here would be 1 plus 9/4, which would be 13/4. So that is what this one would change to. If we were to put 4 in there, it'd be 1 plus 9/4 times 4. That one's going to change to 10. So those would be our new limits. Now we don't need to substitute back in. So what would this antiderivative be? Well, that's like u to the 1/2, so we want to add 1, which would be 3/2. Reciprocal would be 2/3 times that 4/9 we already got, evaluated at 10 and 13/4. Simplifying here, that would be 8/27, and then we'd have 10 to the 3/2 power minus 13/4 to the 3/2 power. And that would be the exact answer here. If you type that in the calculator, it should give you the same value that we got up there. All right, let's try another one. Determine the length of this function between 1 and 4. Now notice on this one is y here. That's a function x in terms of y, and our limits are y. You can still find arc length this way. Just know then that when you're doing this, instead of from a to b, you want those y values. So let's just say, let's call them c and d here, just so we know it's going to be something different. And then this would be 1 plus your derivative. In this case, this would be x prime here that we'd want to square, and then this should be in terms of y. So let's see if we can find that. So this arc length here should be between 1 and 4. It's going to be square root of 1 plus, we need our derivative here. So what is our derivative of this going to be? X prime here would be, we got to do our power rule. So bring down that 3/2. That's going to cancel out the 2/3. Our new power on here should be 1 less, so 1/2. And then you got to think chain rule. So what's the derivative of the inside? Just be 1. So it looks like our x prime comes out to be just square root of y minus 1. So that's our function here, square root of y minus 1 squared, because there's that squared in the function. Now let's see what this equals. So our arc length, I'm going to simplify this first here, 1 plus, if we square a square root, that's just going to end up being y minus 1. Looks like those 1's are going to cancel here, so now we have 4 to 1 of just square root of y. That we can find the antiderivative of. That would just be y to the 3/2 with reciprocal 2/3, evaluated at 4 and 1. When we do that, we got 4 to the 3/2. Now remember, 4 to the 3/2, 3/2 would mean like we got the square root of whatever we're putting in for y cubed. So it would be that minus, same thing, square root of 1 cubed. And I think with this one we can get an exact answer on here. So we got the 2/3 times this. Either we can think of that cubed as inside or outside. It doesn't matter. I think it's probably easier if we think of it as outside. When we do this, so square root of 4 is 2. 2 to the 3rd power would be 8. Square root of 1 is 1. 1 to the 3rd power is 1. That's 7, and so the final answer here is 14/3. So the exact length of that line is going to be 14/3. All right, why don't you pause the video and try this one, see if you can find the exact length on this one. You should be able to here come up with a answer that is a fraction here. So pause it and try out, see what you come up with. Okay, so one thing you're going to need to get this is the derivative. I did rewrite this function here. This is just constant here in front of that. This is same as x to the 3/2. So I just kind of separate those a little bit easier to find the derivative. So bring down our 3/2, our new power is 1 less. Derivative of 1 is just 0. So doing a little simplifying here, these 3's cancel. This goes in here 2 times, so it's 2 squared, so 2 times x to the 1/2, or that's the same square root of x. And then we could combine that. So that is our derivative right there. So now when we do our arc length, we got the arc length from 0 to 1 of our derivative, 1 plus our derivative squared. If you're squaring that, you got to make sure you square both parts, or think of the 2 of these being multiplied together. If you got two of these multiplied together, the 2 times 2 would be 4. Square root of 2x times square root of 2x would be 2x, which is the same as 8x. So now this one, if you're going to find the exact answer, do a substitution here. Let u be equal to 1 plus 8x. There's our derivative, so we're going to end up with this extra constant of 1/8. Now we got to find antiderivative of square root of u, which is like u to the 1/2. So add 1, it'd be x to the 3/2 with the reciprocal of 2/3. Those two constants are the same as 1/12. Remember u to the 3/2 here, that's the same as the 2 on bottom is the same as square root of u, and then the 3 on top would mean like this is being cubed. And so we're going to have the numbers here that we put in. And I did change my limits on this one. I went from 0 and 1, and I inputted that into our u here. So if you find u at 0, that's just, oops, sorry, that should equal 1, not 0. And then if you put 1 in here, you're going to get 9. So our new limits are 1 and 9. So if you go through and do that now, square root of 9 is 3. 3 to the third power is 27. Square root of 1 is 1. 1 to the third power is 1. Keep simplifying, and you should have gotten an exact answer 13/6 if you did it correctly.